You are listening to Humanities Engaged, where we take a closer look at the value of a liberal arts education. I'm Steve McFarland, and I teach philosophy in the Division of Humanities at the University of Minnesota Morris. I'm joined by UMM student and brains of the operation, Adam Kretz. Say hi, Adam.
Hey there, everybody. Thank you for listening. You'll hear me chime in occasionally during the interview with a couple questions, and I'll join Steve afterwards to discuss what we learned.
We are coming to you from the University of Minnesota Morris, made possible with funding from the Mellon Foundation. Please join us as we interview UMM faculty to learn how they teach and why they teach. Today's guest is Dr. Kristin Lamberty. Dr. Lamberty goes by KK. KK is a member of the Computer Science Department in the Division of Math and Science. She received her Ph.D. from the Georgia Institute of Technology. Just a quick side note, Adam had other things to attend to today for this interview, so it'll be just me and KK. He does come in for the wrap-up at the end. We bring you now to our interview.
I came to computer science in a relatively strange indirect path. So I took it as a general education requirement in college at UMM here. It used to be required. And I took it my freshman year because I was really afraid of this computer science thing that I had really never heard of. The only thing I knew about computers was what I had really learned as a Girl Scout. One of the badges, we learned about like computers don't really understand things like we do. They understand binary. Mm-hmm. And so I really envisioned that this computer science course was going to involve me having to understand binary. And I was so afraid of like having a limited keyboard with like just a 0 and a 1. It turns out that that's not at all what it's like. But that was really frightening to me. I definitely don't think like that.
And then so then you took the course and then you got more interested in it, or was it still more indirect than that even?
Yeah, well, I took the course and got interested and thought, I came in thinking I was going to major in French and elementary education because I definitely care about learning and I care about helping kids learn. And I specifically wanted to teach in a foreign language immersion school. Like that was my dream. Mm-hmm. And I guess I sort of always did problem solving kinds of things. Like I was always pretty good at those weird math problems. Mm-hmm. And I had always excelled at that kind of thing. Mm-hmm. And when I found out that computer science was solving those weird problems kind of, or at least there was a part of that, and thinking about process, the idea that all the time when we're writing code, we're thinking about process and we're trying to organize things. I really like organizing. I really like solving problems. Once I figured out that that's what it was, I was like, well, maybe I'll minor in computer science because I kind of like it. It's fun. And then I sort of switched. And it wasn't until I was looking online for some summer research opportunities things. And I came across this lab at MIT called the Media Lab, and there was a group called Lifelong Kindergarten who is headed up by Mitch Resnick, and his work was so inspiring to me, and I thought, wow, I could still do education things. I could still support kids and do fun things with kids and problem solving and learning in computer science. That was what really drove me to continue and really get into it.
So as you mentioned, that was here at UMM. So having this liberal arts education, combining ideas from different areas, computer science, but also education, and that really influenced the course of your life.
Right. I mean, a general education requirement influenced the course of my life drastically. And it wasn't probably, maybe I could have taken that course from someone else. I took the course from Nick McPhee, who's now my colleague. Mm-hmm. And I just really liked the course, and he was such a cool professor, and he taught us in such a flexible way. I felt like he would have take-home exams, and he was like, oh, I don't even care. You can carve it on a door. However you want to turn it in is fine. So there's this major flexibility and interest in how did you solve the problem? That's the main thing. Talking about that process. And so there is a lot of connection. I mean, if you even think about foreign language or world languages and things like understanding each other and being able to communicate, with a computer, it's kind of like we as humans make decisions about how things are going to be represented and how we're going to communicate with the computer. And then when you capture a process by writing a program, you can share that with the world, and people can recreate the process that you've captured and communicate it through code. And it's kind of cool because there's a lot of different ways you can always capture that process. Just like you could tell a story in a lot of different ways, you can write code in a lot of different ways too. Not everyone writes the same way.
Yeah. So then what kind of stuff are you working on these days in the computer science area?
Well, my research still has like an educational technology sort of bent to it. I spent quite a few years doing something where I was trying to help support kids who were making, they could make quilt blocks and learn about fractions and symmetry. And I was trying to like reveal mathematical things about tangible things in the world, things that you might see every day, and helping kids to mathematize like the world around them by providing them with these lenses and tools that were in the software. And I did that for many years, and now I've sort of shifted, and I really have come to care a lot about when kids are learning how to read. So a project I'm working on is to support kids who are just learning how to read so that they can begin to write interesting stories about things they care about. This all comes from sort of this constructionist approach to education that's like we learn best when we're building artifacts for an audience. And so I want to always be focusing on helping people to make something when I'm in that kind of realm, or when I'm thinking about constructionist approaches to how people learn. So now I've provided like physical looking, I mean, they're virtual, they're on screen, but word tiles, and those word tiles have different contexts. So they may be something that you're learning about in school, like it may be Unit 1, Unit 2, words. But then also, if you're a Harry Potter fan, maybe you have like Ron and Hermione and Expelliarmus and Dumbledore, you know?
Yeah.
And if you care about Batman, then maybe you have Batman and Robin and the Batmobile. So having these other words along with maybe a place that you care about. So maybe you live in Morris and you want to have Willie's and East Side Park. And so that's kind of exciting because maybe you want to tell a story about Harry Potter in Morris. So I'm hoping that that would be one way for kids to really begin to care about communicating with the world through language and think about capturing their stories. So that's one project that I'm focused on right now.
Is that supposed to be in tandem with like classroom instruction about reading, or is it substitute for some other things they might be doing, or how do you envision that to be used?
The motivation for me was that both of my children have gone through learning sight words in school. And sight words are those words that you should be able to see and recognize. And they're like some of the most common words, but they don't always follow the rules for sounding things out. And then those words were really boring for my kids. Like they just were like, yeah, whatever. You know, they come home and they're like, yeah, we have to read this thing 3 times. And so they would try to read it like in funny voices or something. You know, it was supposed to be practice, but they just were kind of bored with that. And I'm sure that some kids are engaged with that. It's great. It's good to have that repetition. But for kids like mine who were just really not excited about that, I thought, what could I do to make that more engaging for them? And I really thought they care about those characters in those books and shows, that they care about those things. And if we could give them some context words to put around those sight words and let them tell their own stories instead of just like, you know, see the ball, you know,
Right.
that might be more fun. So that it came from really like a personal experience. I really wanted to bring context into those more boring words.
Yeah, so it seems like throughout your story so far, it's always practical, combining ideas, taking this from over here, then combining it with computer science or, you know, education. And
Yeah, well, I think that, you know, whatever you're passionate about, it's kind of cool because computer science can really augment just about anything. So you could major in philosophy and computer science, and the stuff you learn in computer science is just going to enhance the stuff you learned in philosophy. It's like seasoning. I don't know. It really can add to anything.
Yeah.
And there's so many different things you can do with it. It's really just a tool. You know, I can create technology that can support all kinds of different things.
Yeah. So I interrupted your second research project you're about to get into.
Yeah. So the second project is related to a grant project, and the grant is funded by the Minnesota Environmental Natural Resources Trust Fund, as recommended by the LCCMR. So it's a grant that is not headed up here. It's headed up by Steve Poppy at WC Rock, and it involves a prairie restoration in Morris. So one thing that we were a little concerned about with this prairie restoration project is communication with the community, because people get nervous when you're changing things in the environment, right? Especially along a trail. So they were going to take down some trees, and they were going to be replacing those things that aren't native with native plants to encourage beneficial pollinators in our area. And so my part of the project is really trying to reach out in the community and help inform people a little bit about what this project is going to accomplish, but also to help people understand pollinators and why we should care, why we should restore the prairie. It's pretty nice when we have trees, that's something that's really hard to see go. And they will be planting trees, but they'll be native trees, and trying to sort of restore that native prairie environment for these pollinators. So I've learned so much about pollinators in the process.
I was going to say, interdisciplinary to its core right there.
Absolutely. So, yeah. I mean, I think that as a person who really, when I think of bees, I think of honeybees. And as a kid growing up, I know I always was like, oh, it's a bee. I don't really like bees, but they make honey. Well, it turns out 1 in 3 bites of food that we consume has been touched by a pollinator. It's important. We need those pollinators for our food supply. And some of these native pollinators are really efficient at pollination and really good at it. And we need to make places for them so that they can help us, help them help us. Right. So the project, there's 2 parts that we've done so far. One is working on a website that would sort of give you random pollinator facts, and we're trying to sort of distribute that in the environment here, like in Morris. We haven't done it yet, so don't worry if you haven't seen it. But the idea is that we would provide QR codes at different locations, maybe at grocery stores and restaurants and places where you're just going to be sitting around, maybe looking at stuff, and you might be interested.
And then you could scan with your phone.
Yeah, and it might give you a random pollinator fact. Yeah. And then if you want to know more, you could dig deeper. Because there are so many things I didn't know. There are a lot of bees that aren't social and don't live in a hive, and they kind of live by themselves in a hole in the ground. And I had no idea about that. So things we could do to help support those pollinators. And the fact that they're not active, some bees are only active for a very short time span. And when they emerge, there's nothing for them to eat. That's problematic. Yeah. So the second part of the project that we've been working on is a participatory simulation. So what you would do is maybe have 20 people or something. It could be kids, could be adults, could be people of all ages in the community. Gather maybe somewhere at a library or in a classroom. And we're going to have each person can sort of pretend to be a bee, and we're going to show them those bees on a device like an iPad or a phone. And then we're going to have them walk around in the room that they're in and, scan different flowers. Well, what happens when I scan this flower? Maybe that's a flower that I really like, and I can get a lot of nectar or pollen from that flower. Or maybe that's a flower that's not blooming right now, and so I might not get anything from it. Or maybe it's a flower that has a certain morphology, a certain shape or aspect of its the way it's made or the way it's built, that means I can't access the nectar because I don't have the right shaped tongue. So there's all kinds of different nuances that as a regular person, eating foods that bees have pollinated never really occurred to me. I didn't really know that there were some kinds of things they get from certain flowers and other kinds from other flowers, or there's certain flowers, apparently blueberries have to be buzz pollinated. So bumblebees are good for that because they have the mass to sort of wiggle enough and really shake that pollen. And there's just so many things I really didn't know. And I think that these little things we can incorporate, and people will walk away hopefully from participating in this simulation with just a little more knowledge, just a little more something to bring out into the world and help them feel engaged with, let's save these pollinators. It's really important.
Yeah. And then, so there's always a practical bent to what you're teaching here. So in your classroom, do you you said you take this constructionist approach, and you're having people build things. Is that the kind of assignments that kind of tasks you give in the classroom?
Yeah, I try to do that. So I think the constructionist idea that we're building, we learn best, most felicitously when we are building artifacts for an audience. Okay, well, what does that mean? In a class, sometimes you're writing something and it's really just for your professor, but that's still an audience, right? And so you're still thinking about the thing that you're going to be writing about or working on, and how will I communicate that with my audience, whoever that audience is. And sometimes when you're writing code, that audience is future you, because if you write something that's really hard to read, it's going to be hard for you to read later, and you're not going to understand to be able to fix it or update it.
And by hard to read in coding, it's not handwriting. It's not handwriting,
No.
right? What's that mean for
so
audience?
There are ways you can write code that are easier to understand for humans, and for your future self. So one of the things we get to do in computer science is give a lot of things names. And when you're picking a variable name, it makes a lot of sense these days to pick a descriptive variable name, something that really tells you, what is this thing doing? You could name it Bob or Fred or Tony or whatever you want to name it, but it's not going to help you to do that, right? So if
you come back years later because you found an error and you were like, what is Bob variable supposed to be?
Why did I call that thing Bob? It's a picture, like it's really helpful to give those variables useful names. And so that's part of communication, right? When you're communicating with the computer doesn't care as long as you're consistent. You can spell pancake totally wrong, but as long as you spell it the same way everywhere, the computer is like, that's the same variable. But for yourself, it's helpful to give useful names. So that's one part of communication and the kinds of assignments I give. The other thing is I really do believe that projects are really important. And when you're making a project that has a motivation, it really is easier to get engaged with that and really dig deeper and to make those personal and learning connections in what you're doing. And I do find that students seem to respond well to that. Everyone likes it to be meaningful.
Yeah.
So in the introductory course that I have the privilege to teach most often, we're doing stuff with multimedia. So people are working with pictures and sounds and making animations with code and strings and other things too. But pictures and sounds are the main things that I think people feel really engaged with. And the picture part especially, because it's really easy to take a picture. People have a lot of technology at their fingertips to do that. So people can use their own personal pictures, and they're not just editing a string of numbers or something kind of dull. You can really make something cool that you might actually care about.
Yeah. A number of teachers have been saying giving authorship to the students and ownership, so sort of don't just recite back to me exactly what you've learned in class. Make sure you use the right key terms and define them. And that's not that there's something wrong with that per se, but if they can make it more meaningful to themselves, they're that much more motivated to get it right, to really perform, up to the expectations that you have for the project or something like that. Is that?
I think so.
Yeah.
I think that's true. Yeah. The excitement of making a photo collage with pictures from, a gathering with your friends, it's kind of more exciting than just putting some numbers together or something, and all those things can be done with computers. So it's sort of nice that that the processing power has increased so much that we really can do these things even if our code's not very great. It can still work. Things are fast enough now that even if your code isn't perfect, it's still going to eventually finish.
Yeah. And another thing you were mentioning is that the communication is just vital to the project, which again is kind of interdisciplinary, right? So, when we do a lot of writing and philosophy, and an important thing for I think all teachers to do is give a sense of the audience of the project, no matter what it is. And it sounds like in your work, in instruction, you're constantly emphasizing who's seeing this, what is the nature of the people who are going to be
right
on the other side of the screen from you.
Yeah, it matters. And I think, so I care about usability of technology. I care about the frontier where the humans and the computers are interacting, right? That's where I live, right? So it's really helpful for students to think about, if I didn't know how this worked, if I am approaching this technology that I'm making right now, and I don't know what's going on, will I be able to figure it out? Like, have I made that clear to the user?
Yeah.
So thinking about that usability aspect, and like, there are lots of choices for how we could input a phone number, but probably it makes sense to structure the field, so that it's clear what it's going to be, or, just make it as easy as possible for people to do the thing you want them to do with the software.
Yeah. So what makes most sense to you with your knowledge base is not necessarily the same thing as what makes sense to someone who's coming from a different background.
Sure. And not even just what makes sense to you, but like, you might not even be thinking about what makes sense. You might only be thinking about what works. And there are a lot of ways it could work. There's a really fun, it's like a competition sort of online. If you look for like really terrible ways to enter a phone number or something like that, it was sort of like all these different interfaces you could use. And there's like a scroll wheel with like, numbers like 00000, and then like you have to scroll to get to your phone number. That sounds terrible.
Yeah. like unlocking like a luggage lock.
Just keep spinning.
Yeah, right.
So there are a lot of terrible ways you could ask people to do something, and all of them would work, but not all of them would work well.
So is that how you assess them too? Is how well do they pull off making this usable? Is that part of the criterion?
Well, so it definitely depends on the level, of the assignment and what class it is. I try to use rubrics when I'm grading something. I think it's important to help steer people towards the learning goals that I have, to provide them with information about what it would mean to perform well on this problem. So in software design class, then I'm going to care if it's usable, right? I'm going to be asking them, partway through the course, like, okay, now you've been making things that work, but I want you to think now about how that would be from a usability perspective. Like, someone using the software, would they really want to do it that way? And ask yourself that. So that's an important thing to be able to think about and reflect on.
But that's like a higher level skill. For lower levels, that's not the main thing you're worried about.
Probably not. I mean, but they don't really build something that's meant for a wider audience until probably software design. In a 2000 level class in data structures, they might be solving problems. They may be writing code, but they're probably not making a user interface. So maybe it doesn't yet matter. But that doesn't mean that they don't write code that's interacting with other code in a way that makes sense. So you want to also think about how other programmers could use the code you're writing, or how it might integrate with the rest of the system. And so we do encourage them to think about how things fit together, even if we're not like really looking at usability.
Yeah, there's still an audience. There's still some other communication.
Right.
It's interesting. So then, usually I'm interviewing with Adam. He couldn't be with us today.
Sure.
But he wanted to ask in particular, how do you view the centrality of computer science to like a liberal arts education? Should everybody be getting computer science classes? Should it be something that can you safely ignore that in your education, or how where do you? So some people will say, like, you should take a composition class. Like, everyone should be able to write, everyone should be able to communicate that way. And then you might think there's some classes that are more distant from that center. Where would you put computer science on the spectrum, especially with technology is not slowing down? So.
Yeah, technology is not slowing down, and it's more and more integrated in everything that we do. So I guess the question is, what do you want to be able to do? And if you're fine with other people controlling what you're able to do, then you don't need it, right? Like, if you're just like, if people are willing to support me in this way, that's great, and I'll take it. But if they don't, then fine. But if you actually want that kind of, like, you want to have a little more control over ways you can express yourself and ways that you can interact with the world and do your job, like, you might want to know a little bit about how computers are working so that you can communicate with computers in addition to communicating with people. So it's not a gen ed requirement right now. It's not required. As a person who only came to computer science because it was required, oh man, that makes me sad. We're missing the KKs in the world now. Like, that maybe is fine. Like, maybe there are enough people interested, but the industry wouldn't say so, because right now, like, there's a shortage. There are more jobs than there are people to fill them. And I think it's a little sad because I think people are afraid of computer science. I think that they hear it and they think like, they'll ask me something like, oh, what do you do? I'm like, oh, I teach computer science, or I'm a computer science professor. I do computer science research and teach computer science. And they're like, whoa, you must be really smart. And I'm like, well, like,
yes, but also,
or, like, it's hard because, Minnesota, like, I'm like, oh, maybe a little bit, I guess. But like, you don't have to be super intelligent, right? It's not like harder than other things. It's different.
Yeah.
And so maybe there's a certain way of thinking that does support me in this way. Maybe I notice patterns. Well, I do notice patterns, and pattern matching is definitely a skill that in computer science is really helpful.
Yeah.
But I'm not particularly mathematically inclined, actually. Like, I enjoy solving weird problems in math, but I took as little math as I could as far as like I did like my minimum math requirement for a computer science major. And that's one thing that makes, that I'm a little different from a lot of computer scientists. A lot of computer scientists also really like math. And I think it's a nice tool.
Yeah.
But I don't.
But there's space for someone doing computer science at high level that's not math focused or
right.
as central as it might be.
Right. Yeah. Like for me, I just am not a huge mathy person. I don't know. Not my favorite thing.
Yeah. But you're doing fine. So
I'm doing
fine. That's the point. Is that
yeah.
There's room for.
I got a Ph.D. in computer science, and I have
not
done
to brag,
in minimal math. I mean, I did Calc 1, and I did probability and stochastic processes, and I did geometry. I think those were the 3 math courses that I did in college. Oh, and math perspectives or something. Like I did maybe 4 classes. I didn't do any more than the minimum though. I just did what was I needed to do.
So in other words, more people should be going into it, and fewer people should be as maybe
afraid.
Wary, as they might think that
Yeah, I think if you like solving problems, that there's a space for you in computer science. It would be really hard if you were terrible at pattern matching. Like if you couldn't look at something and say like, oh, that's really similar to this other thing. If that was really hard for you, then this might be challenging. But it's not something that if you don't have background, you're going to fail. That's definitely a thing where like some people come in and they're like, well, I'm in college and I haven't even started any programming. And then I hear, people who live down the hall from me and they've been like coding since they were 6 or something. And how can I major in the same thing that they're going to do? Well, sure, they've been coding since they were 6. That's great. Fine. But you can get started anytime.
Yeah. So then if a student wanted to do particularly well in your classes, if you could give them an extra piece of advice beyond the show up to class or whatever, is there any tips you have for student success?
I think that for almost any class, the thing that you're most afraid of is the thing you should practice the most. And in computer science, many students in an introductory course are going to be afraid of the coding parts of it. And there is quite a bit of coding, we do that in our intro courses. Well, we do that in a lot of our courses. But I think that if you're practicing a little bit every day or just after class, take that code that I post on our campus website, on Canvas, like take that code and try it because we've just done it in class. And so if you can run it and you can try it and you can change it a little bit and see what it's doing, that's going to be really helpful. That practice matters a lot.
Yeah. Is this a fair way to say what you're saying, that you should work on your weaknesses rather than trying to continue to build on strengths? Is that how you're viewing it?
Not rather than, but maybe like make it a focus, make an effort towards that. Because of course it's more fun to do the things that you're already good at.
Yeah.
And it's fine to have fun.
Do you think it's how easy to tell what your weaknesses are? Is that something that people would just know pretty quickly, or can it be hidden weaknesses there?
Well, I guess you might not know what your weakness is, but I do have a fair number of students who are just kind of like afraid to make that step. They're afraid to try it at home because they are like, well, what if I get stuck? And it's like, well, you're going to get stuck probably. And if you don't do it now, you're going to get stuck later. So better to just get stuck a little bit now and then get over that, work through that because I'm there to help,
Yeah. So maybe the way I phrase it is not as, so maybe a different way to think of it is, don't avoid the challenges, because the challenge is going to be there no matter what.
Right.
So you might as well get started on digging your way out of the challenge.
Yeah.
Because everyone's going to face them. Is that the...
I think that's true. Yeah.
Okay.
Everyone is going to face those challenges. And if you take them head on, just face them. Yeah.
Mm-hmm.
Don't run away from your fears and then come to me 8 weeks into the semester. Like, I still don't really know how to do this thing from 8 weeks ago. Oh, I'll help you, but I feel so bad that you struggled for 8 weeks and didn't try that part because you were stuck.
So are these classes usually cumulative? Is there a lot of building on the basic ideas? Okay.
Yep. So we're giving all along, we're introducing tools. And if your toolbox isn't collecting those tools along the way, you're going to suffer later when you get to something more challenging.
Yeah, because I teach a logic class sometimes, which, of course, computer science has a lot of overlap there.
Yeah.
And I tell them, this is cumulative. If you don't get the basic stuff now, then the rest, it's going to be very painful as we go.
Right.
So don't think, well, I don't get this now, I hope I'll get it later. Right? That's the attitude. I mean, I've had attitude like that sometimes.
Yeah.
It's just not the right one for certain courses.
No, it's hard.
Some courses you leave stuff behind and you can kind of skate through for a unit or two. But for some courses, it's just not how it works.
It's not going away.
Yeah.
I always tell my students, like, the exam's going to focus on the recent stuff, but it's kind of cumulative because we can't avoid that. Like, if you have forgotten how to do the stuff we did in the first couple of weeks, it's going to hurt. So you're going to want to study that too if you have forgotten.
Yeah, that makes sense. So is there a big substantive idea your students get from taking your classes that everyone... So an example is in anthropology, the human diversity is something that you hope someone 20 years after the anthropology class can think back. If you say, what do you remember from anthropology? Oh, there's so much human diversity. Is there something that you hope that the idea that can get across, either you do it in multiple classes or your intro classes, you make sure that this is an important thing to take away?
I guess one thing that I think is important, I don't know if it's the important thing, but I think one important thing to understand is that really computer science is the study of process. So there are going to be some people who focus on making those processes faster and more efficient, like to work, so they focus on algorithms. And some people might be like, the part of the process I care about is where the people are interacting with the computers. Because if that slows down, like if people can't understand it, then no matter how fast the computer is, then things are going to still be pretty stinky. And some people are working on hardware and they're trying to make those processes run faster on the computers. But it's all kind of related to process.
Yeah, and then you focus on that middle, the interface. That part of the process. Yeah,
because if people can't figure out how to use it, then it's not going to get used and be useful.
When you say process, it's this kind of important idea. Can you specify what do you mean by that? I mean, I know the general idea, but
I guess central to computer science and process, we're talking a lot about writing instructions for the computer, and those instructions tell what needs to happen. You might think about process in a lot of ways, though, like in your daily life. I mean, one example that's often given for an algorithm is like lather, rinse, repeat, you see that on your shampoo bottle, and it's actually a dangerous algorithm because it doesn't really say like you should stop. So you could just be stuck in an endless loop, like, oh, I'm following my shampoo instruction. But I guess as a computer scientist, I feel like when I view the world, I'm often seeing places where things could be improved, like just little tweaks to the process. Like, oh, really? This is how we're going to do this? You get in line at the grocery store and there's like 6 different lines to pick from. And that doesn't seem like a very efficient way to put us through.
Boarding planes, it drives me nuts.
Yeah. So there's a lot of ways where I think like, oh, my training as a computer scientist suggests to me that this process could be improved. I don't know. I just notice process. If you take my class, my human computer interaction class, then I think that people are going to never look at doors the same way again. And that's partly just because we look at some of the things that are around us in the world, what those things afford. Like, what is this door trying to tell me? Like, this door tells me I should push. It has a bar. It's really clear.
Right.
Well, what if all the doors look that way and some of them are supposed to pull? That's probably bad design.
Yeah. And we don't notice it until we bump into the problem.
Right. Or if you if you've been alerted to that's a thing that might, that there might be indicators, or
Yeah.
there might not be, and there should be.
Yeah.
Then you notice those things. You notice those places where, like, someone could have done a better job communicating what this door is supposed to do. you
Yeah.
know, and doors are just one example that's pretty common. But there's a lot of things that we do where there's a process that's indicated by the things around us that are telling us what we can do. And when you're making software, you have to include those indicators. You need to help people know what can happen in this software.
So then, is there anything in terms of process or methodologies, if you're going to think like a computer scientist? I guess you've mentioned a little bit about that, but if you were going to think like one or research one like one or something like that, what does that look like?
To do research as a computer scientist, or like
In terms of what do you want all of your students to walk away and think differently than they did before?
The toolboxes that I'm helping people build, right? The
Yeah.
tools I'm trying to provide my students are so different in an early class versus a later class.
Yeah.
So like in an introductory class, I'm providing like these really tiny building blocks, like, can you use if? Can you use a for loop? These things that are used over and over again. So if they could leave my class and just know, like, my goal when I'm writing code is to encapsulate and communicate some process, that would be big.
Mm-hmm.
Like, if they understood, like, why I would bother writing code, or are there opportunities in my life for automating something that is tedious or boring, repetitive, and prone to error? That would be a good opportunity for automation with computers,
Yeah.
So that's one thing I would like them to take away, is like, you might actually want to use this. I think that when I took computer science and when I majored in it, people told me that, like, you might someday want to write a program for fun, to do something for yourself. And I was like really skeptical about that. I didn't think that was ever going to happen. But then I did go to a conference and I didn't have access to my Photoshop kind of stuff. And I wanted to make this picture bar. I wanted to make a bar of all the little quilt blocks that were from my research. And I was like making a web page, pretty basic stuff. And I just wanted to connect these pictures all together. I didn't have a good way to do it except for by writing code to make a picture out of all these little pictures. And I was like, oh my gosh, I really did it. I wrote code just for fun for myself because I needed it. And I didn't have the tool I needed at that time.
Right.
I didn't have software that could do it for me. And I was like, wow, that's kind of cool.
Yeah. Now it could occur to you, create it. Whereas before, none of you even.
It wouldn't have crossed my mind.
Yeah.
I would have just probably waited till I got back, till I had my tools again.
Yeah.
But I don't know, you're developing these ways of thinking and ways of approaching something that I hope could be useful.
Nice. Well, thank you for your time.
Yeah, thank you.
Thanks again to KK for a great interview. Professor, what did we learn today?
Well, I thought it was interesting how KK kept finding issues in real life and things that, she talked about how helping her children get more interested in reading caused her to think about problems she could work on that front. And I think that teachers can only do so much to get students to take personal interest. I think they should try, and there's always more that teachers can think about. But I think a good idea for students is to sometimes think to themselves, how could this apply to things I care about, and not give up too easily. Sometimes it's easy to think, because I couldn't think of something right away, that there is nothing it applies to. But if students are thinking about how this applies and how I could solve a problem with this, you have this double benefit. You might start to actually solve a problem or think of new ways to approach a problem at least. But also you're going to be practicing and rehearsing the concepts that you were learning about. You're going to be going over them in your mind some more and looking at the angles of them and, stretching them and seeing where they apply and where they don't. And that itself is a form of studying, right? It's not memorizing, it's not reviewing, but it's attempting to understand how a concept works and where it doesn't work, and that itself is part of the educational process. So I think there's some benefit for students to be thinking about how can I apply this to my personal life? Even if the teacher doesn't reach out and invite you to do that, teachers should reach out and invite you to do that, but students can be doing that on their own as well.
Yeah, that's especially interesting. I had one professor who said, like, it's really important that you kind of interact with the ideas that you learn about. And that's really stuck with me, because you go to class, you learn a lot, you take notes during that whole class, and then what, right? And in order to have, I think, some more concrete or tangible grasp of those ideas, you do have to think something about them. And so, yeah, if you're thinking, how does this relate to my personal life? At very least, it is a prompt to go, well, what is this thing that I have to relate to my personal life? And then you have to clarify your sense of it. And that by itself seems like it would have some benefit, at very least for your memory of it.
Yeah, I totally agree.
And that concludes this episode. Links to the references our guest mentioned can be found in the show notes. Before we go here, a big thank you to the Mellon Foundation and the Humanities Division for supporting this podcast. The views and opinions expressed are solely those of the individuals participating and do not represent the University of Minnesota Morris or the University of Minnesota system. You can find our podcast on iTunes or anywhere you get your podcasts. And if you want to help out the show, please leave us a review on the iTunes store or share the podcast with others. Thanks for listening.
This has been Humanities Engaged.